All right, so today we're going to be starting section 2.1, writing and graphing inequalities. I know yesterday I went over quickly the four inequalities that we're going to be seeing, the four symbols, and they're here. This one here is less than. Oh, because it's frozen. So this is less than, and less than kind of looks like a L, which helps you remember that would be less than, and then the opposite is greater than. When you have a little line underneath of it, that means an equal to as well, so you can have less than or equal to, or if you flip it around, it can be greater than or equal to as well. So yesterday I went over that some key phrases we can use also would be like fewer than, more than, is at most, is no more than, is at least, is no less than. So this is just a recap. I know I taught this yesterday before you guys started IXL. But what we want to do now is go over the examples with how to write inequalities. So here I have some examples with little word phrases, and we're going to be going over how to write these as inequalities. So A says a number W minus 3.5 is less than or equal to negative 2. So all of this stuff is important. This is all going to help us determine what the inequality would be. So the first thing they say is number W. So I'm just going to start with W. And then they say minus, which is pretty obvious. It's subtraction. Minus 3.5. And then we have to just determine what symbol this would be. Is less than or equal to. So you would look above to the different symbols, and you would see that less than looks like this, or equal to has half of the little equal to sign like that. And then the number that's less than or equal to is negative 2. So this would be the inequality you would create here for that first one. So it's kind of like section, I think it was section 1.4 maybe, where we were creating word phrases from algebraic expressions and vice versa. This is very similar, but now it's inequalities instead. So the next one says the temperature T in Sweden is at least negative 10 degrees Celsius. So what we really need is just the variable we're talking about, the symbol we're going to need, and then the number that's going to be being compared. So the temperature T is at least. Now, I know when you see the word at least, you might be thinking, okay, least less. It must be less than, or less than or equal to. But you really have to think about it. If it's at least negative 10 degrees, what symbol would that be? If it's at least, Eli? Perfect. So at least means that negative 10 is the smallest number it possibly would be. So that means it would be anything bigger than negative 10 or equal to is fine as well. The elevation E of Alabama is at most 2,407 feet. So sometimes it's helpful just to set up the variable and set up the end point, the number you're talking about, and then determine what symbol this would be. At most. What symbol would represent at most? Which is kind of representing like the largest it could be. Anyone else?
Is it less than or equal to?
Yes, perfect. Less than or equal to. And these are tricky. You have to really think about it. If it just says literally less than or equal to, like you'll know exactly what to write. But if you're not sure, because it's not saying that, it might be saying at least or at most, you have to really think about what it's saying and then determine, okay, is this elevation going to be more than 2,407 feet or is it going to be less? And you can really determine that from the wording of the question. All right, the next one says an upcoming marathon's qualifying time is 3 hours. Will a runner with a time of 3 hours and 9 minutes qualify for this marathon? So an upcoming marathon's qualifying time is 3 hours. So if you are going to be running a marathon, you would have to do it under a certain amount of time. So in order to qualify for like the Boston Marathon, which I know is huge, you have to have a specific qualifying time, and that will be the cutoff. Anything less than that, they'll let you in. Anything more than that, they will not let you in. So the question is just asking us, didn't say to create an inequality at all. We could say that the time would have to be less than or equal to 3 hours to help us determine it, which will help us answer, will a runner with a time of 3 hours and 9 minutes qualify for the marathon? No. Because it's still fast, but they're too slow for the marathon cutoff because of the extra 9 minutes. Okay. All right, if we flip this over to the next page, there's some practice problems on here, 1, 2, 3, 4, and 5. For those of you in class, I would like you to work together on these. For those of you at home, you can work independently, and then we'll go over the answers in a few minutes. I'll scroll down so you guys can see the rest of them. It just goes to 5, so I'll just scroll down 2 to 5.
What is the difference?
All right, let's go over these. So number 1, you must be at least 16 to get your driver's permit. It doesn't tell you what variable to use, so any variable that you decided to use for this is fine. What inequality did you create for number 1? Anyone here want to answer? Jace?
16. I think that's greater than or equal to T
T?
or P. Permit.
Okay. It doesn't matter what variable you use. I didn't hear if it was a P or a T. So Chase decided to do this a little bit different. It's still correct. This says 16 is greater than or equal to the permit for your driver's license. My brain doesn't work that way, but this is totally right. This is saying 16. Wait a second. This is actually backwards. Sorry, Chase. So sometimes my brain doesn't work this way, and this is exactly why. I like to have my variable come first. So we're going to use the same variable and the same number, and we flip the numbers. The symbol that Chase used will be correct. In order to get your driver's license, you must be at least 16 years old. So you have to be greater than or equal to 16 years old. This one actually says less than or equal to 16. I know this symbol says greater than or equal to right now, but when you read these inequalities, you read them from wherever the variable is. So since the variable is on the left, I would read it from left to right and say driver's permit is greater than or equal to 16. This one I would read from right to the left since the variable is on the right, and that one would say your driver's permit would be less than or equal to 16 years old, which would mean like you could get a driver's license when you were like 2 years old, which is not the case. You have to be greater than or equal to 16. Now, the reason why at first I thought it was right was because sometimes people actually do think of it the opposite way and write the 16 first and write the variable second. And what happens, though, when you do it this way, you would have to flip the sign so the sign would still match up. These two answers, greater than or equal to 16, and this one, the 16 is less than or equal to P, are actually equal. If you read this one from the variable from left to right, it says P is greater than or equal to 16. This one, you would read it from right to left. It still says P is greater than or equal to 16. Back in the day, maybe when you first learned inequalities, your elementary school teachers, when you first got introduced to this topic, would make this, that's why the beginning of this has like a Pac-Man or maybe an alligator or something. You would always eat the bigger number. Well, that's what happens when you flip the inequality signs. It still works, but you will have to make sure that you're not just keeping it the same, or it will actually be the opposite answer. All right, number 2, you can earn at most 100% on your report card. Again, there's no variable, so you can use any variable that makes sense to you. What did you guys get for number 2? You can earn at most 100%. John?
C is less than or equal to 100.
Perfect. C is less than or equal to 100. All right, number 3. 12 is greater than or equal to 5 times the number n. So there's a lot going on in this one. So it says 12 is greater than or equal to. So I'm going to start with that. 12 is greater than or equal to, and then it says 5 times the number n. This compares or connects to what we did in the last chapter in the last packet. 5 times the number n would be 5n like this. Now, eventually what we're going to be doing is solving these types of inequalities, but so far we're just writing them. All right. Moving on to 4 and 5. Number 4 says 7 is less than or equal to the difference of a number q and 6. So, a lot of things going on here in this one as well. So, let's just start here with this. 7 is less than or equal to, and then the difference of a number q and 6. What would that be? The difference of a number q and 6. Chase? I'm only calling on you because I heard you arguing with Alex and you were right.
7 less than or equal to 9 subtracted by 6.
Yes,
Oh, that's Q.
it's a Q. But yes, you're right. So I call him Chase again just because I heard him talking about how the difference is subtraction. And I know a lot of times at this point you might think the difference might be something else like divide, but it's subtraction. So that would be your answer for this one. And then number 5, 0 is greater than or equal to. So I'll start with 0 is greater than or equal to, and then twice a number x plus 1. What would twice a number x plus 1 look like?
2x plus 1.
Perfect, thanks, Eli. 2x plus 1. All right, so that's the first section, or first part of this section, which is just writing inequalities. The next part that we're going to learn is kind of just rephrasing what I taught yesterday quickly in our little mini lesson. If you flip this over to the next page, we have here the solution of an inequality. I know that I went over this, and I know that you did your IXL on this, but I'm still going to quickly go over it, but not as much as I did yesterday. So a solution of an inequality is any number that makes the inequality true, and every inequality usually has infinite solutions, has more than one solution. So for these inequalities, we are basically asking if this value is an inequality or a solution, and yes it was, because when you replace it in and solve, you got a true answer. This one is also a solution, because when you replace it in and solve, you get a true answer. This one is not a solution, because when you plug it in, you get a false answer, which means it's not a solution. So in example 2, we're trying these on our own. I think I did this one with you, but just for a completed note guide, I'll do it again. So this says x plus 8 is less than negative 3, and we want to see if negative 12 is the solution. So to do this, we would replace negative 12 in for x. And then we would just solve using the order of operations on this side. Negative 12 plus 8 is negative 4. And then we think about the answer here. Is this true or not? Is negative 4 less than negative 3? That means is negative 4 smaller than negative 3?
No.
I hear no's and I hear yeses. So let's look at a number line.
Oh, yeah,
So it really honestly is confusing when we have negative numbers, because when you have positive numbers, 4 is bigger than 3. So we know that because we're so used to working with positive numbers. But when we have negative numbers, the number line is basically flipped, because it's a mirror image of the positive side. So this one, if we're looking at negative 3 and negative 4, negative 4 actually is smaller than negative 3 because it's farther away from 0. Because of that, the answer is yes, that negative 12 here is a solution to that inequality. For the second one says negative 4x is greater than negative 21. We want to see if 5 is a solution. So we're going to replace 5 in for x, and we're going to solve and see if this is true. Negative 4 times 5 is negative 20. So we're left with this statement. Negative 20 is greater than negative 21. Is that true? Yes. So 20 is closer to 0. So this would be a solution as well. There's 3 practice problems on this page that I would like you guys to try, so I'll give you a few minutes. Go ahead and try 1, 2, and 3.